So let's go ahead and leave this way. Let's leave this way for now. Now, for our remote implementation or repository implementation, we will simply come over here, create our authentication remote data source. This is how it's simply going to work. We create that data source, and we remember that our data source is going to be throwing exceptions at us when there's a problem. So we will take the data source dot create user, and we pass in these things in there, and then we do stuff with the result. We return it here. If there's an exception, we handle it as well. Now, that's all great and well, but remember, I'm trying to explain what dependency inversion is. Dependency inversion is simply what we do when we take the dependency in the constructor. It simply means that we're creating a space for injection to occur. If we wanted to inject something into this class and there's no space for us to inject something into it, then there's no way for that injection to happen. But if we wanted to create a space for injection, we do that through the constructor. So whenever you take something from the constructor, for example, a remote data source, which is a dependency of this class, because we know that this person will need a final data source, and then it will use that data source to call create user. This person will also need that data source. Instead of creating that multiple times, we simply inject it into the class. So that way, we can use it without having to instantiate it multiple times, and also it helps us when we're testing, so it makes our class testable. You might have heard it a lot of times. You write testable code. What does it mean to write testable code? This is part of what it means to write testable code. This is a major part of it. If you don't inject your dependencies, then when you're writing a test for this class, how do you control? Remember what testing does. When we ask 3 questions, and those 3 questions, part of it is, how do we control what our mock? How do you even start mocking your dependency? After you create a mock of your dependency, for example, a remote data source, imagine that we're not taking it in the constructor, and we have our final data source in here, equal to, and it calls create user, and we also have another final data source in here. And then finally, in our test, when we're creating our test, we create that mock data source, extends whatever. After doing that, how then, when we're testing these functions, are we going to pass in that mock version into this? How are we going to do that? You can't do that. So in order to make your code testable, we need to make it so that our class is injectable, so that we can inject our mock dependencies into the class. This is the entire reason why we're using a dependency inversion. So dependency inversion is simply, instead of taking this dependency in here, we invert it and inject it into the class directly. So in here we do this dot remote data source, and I prefer to make all of my dependencies private. So that way, because dependencies are meant to be dependencies for the particular unit, right? We don't, remember principle S, single responsibility principle. We don't want other classes or other units to control or control whatever happens inside of this place, except we're in a test. So we don't want other people to be able to control what the remote data source inside of this class does. So we're going to make that private. We're going to take that in the constructor remote data source, and that's it. So in here we will be using that remote data source that we've injected, and we will use it to carry out our functionalities in the method. Now, the principle of TDD. Remember, the course is about clean architecture, the principles of solid, and the principles of TDD. The principles of test-driven development. Test-driven development. Oh, sorry, my fonts is low again. Not plugin settings. Fonts. I've got to put that to 16. All right. Yes. So I hope you can see that better now. I'm so sorry for not putting it up earlier. The principle of test-driven development. Test-driven. It's driven by tests. So we are going to be writing our test first before we actually implement the functionality. So in order to write the test first, we need to know what we want our method to do. So we're going to be writing the test for the create user method before we actually implement that method, before we write the code that will do that. So we want to be able to know what we want our class to do. What do we want the method, rather, not the class, the method create user to do? We want create user to, first of all, we want it to call the remote data source. So you break it down. This is usually, you can actually follow these testing principles for all of your repository implementations. This would work across the board. This is why clean architecture is so beautiful. The moment you learn how each module works. For example, this module, right? This module, how this module works and how the test is written. The process that it goes into creating the test for this module. You no longer have to learn a different way to write tests for it. It's simply, you're just going to be writing tests the same way for every repository implementation. You're going to be writing tests the same way for every remote data source. You're going to be writing tests the same way for every module, every use case, and so forth. So how do repository implementation tests work? First of all, you test to make sure that we are calling the dependency, in this case the remote data source. If you have a different dependency, you would also write a test to make sure that you're calling that dependency. Secondly, you check if the method returns the proper data. What does that entail? Let's go deeper into that. So we're on the small, so this is on the larger scale. This is what we're checking, if the method returns the proper data. So but then what does that actually mean? On a smaller, when I break it down, what does that actually mean? We're testing to check if when the remote data source throws an exception, we return a failure, and if it doesn't throw an exception, we return the actual expected data. This is what we're doing for the test. Let's go ahead and write our test. So